Hi, this is the second video in section 5.2. The first thing you want to do is open your journal to page 130 and copy down the definition of simplest form of a radical. Next, look at page 131 of your journal. There are two properties of radicals here that we'll be using. Basically, if you have the same radical, two radicals, you can multiply them. So you can bring them under one radical. Or same thing with division. If you have one big fraction under a radical, you can split it up into two. Take a minute and look at the examples that you see here. Now let's move to your notes packet. Let's look at example 2, where we want to use the properties you just looked at in your journal to simplify each expression. With multiplication, since they're both the same radicand, so they're both cubes, you can multiply these two together, 12 times 18. We can then multiply 12 times 18, but instead of doing that, we're going to eventually have to factor tree anyway, so I'm just going to factor tree now. 12 will be 2 times 6, and 6 is 2 times 3, where 18 can be 3 times 6, and 6 is 2 times 3. Now, because it's a cube root, we're looking for trios. Every time we have a trio, so we have 3 2's, and we have 3 3's. So we can write our blank cube root. We have a trio of 2's, so that can come out, and a trio of 3's can come out, and there's nothing left, so we actually don't need this radical, and you can multiply 2 times 3 and get 6. Now let's look at B. Right now it's written as two separate radicals, but since they're both fourth root, we can make it into one and make it 80 divided by 5. Which reduces to fourth root of 16. And now you can break down the 16 or just know that 2 to the fourth power is 16, so your answer is 2. Now let's look at example 3. We're going to continue breaking down radicals. So 135, we want to factor tree as much as possible. I know 5 goes into it because it ends into 5 27 times. 27 is 3 times 9. And 9 is 3 and 3. Because it's a cube root, we're looking for a trio. Here's a trio of 3's, so I can take the 3 out, and the 5 is by itself. So my answer would be 3 cube root of 5. Let's look at B. The definition of simplest form says we're not allowed to have radicals and denominators. But because this is a 5, we need 5 of whatever number for it to come out of the radical. Right now, if we break down 8, 8 is really made up of 3 2's. So I actually need 2 more 2's, or 2 times 2 is 4. So I need to multiply by the fifth root of 4 on the bottom and on the top. So on the top, I have 7 times 4, which is 28. And on the bottom, I have 8 times 4, which is 32. And the fifth root of 32 is 2, and you won't be able to simplify this top most likely. Please write any questions down that you might have so far. Going back to your journal, page 130, you should then write down the definition of conjugate, and you might as well write down the definition of like radicals while you're also at this journal page. Now let's look at example 4. With example 4, we have a radical in the denominator, which is not allowed. But because it's a binomial, or it's got two pieces, what we have to do to get rid of the radical is multiply by the conjugate. The conjugate will be basically the exact same expression, except the signs will be different. So in the original problem, it's a plus sign in the middle. So the conjugate will have a minus sign. So what we need to do is multiply the numerator and denominator by the conjugate. So you can see we're multiplying the numerator and denominator by the conjugate. So now let's do this. 1 times 5 minus radical 3 is just itself. 1 times anything is itself. In the denominator, we're multiplying these two together, so we're going to have to FOIL. 5 times 5 is 25. 5 times negative radical 3 is negative 5 radical 3. Radical 3 times 5 is positive 5 radical 3. And then radical 3 times negative radical 3 will be negative radical 9 or just negative regular 3. Notice the outers and inners will cancel, and that always happens. And then we can actually combine 25 minus 3 and get 22. So 22 will be my new denominator, and the numerator will be 5 minus radical 3. So you can see in this final answer, we no longer have a radical in the denominator. Now let's move to example 5. We will be adding and subtracting like radicals or roots. So this can be very simple. If you look at 5a, these are exactly the same, 4th roots of 10, which means we can then add their coefficients, 1 plus 7, and get 8 4th roots of 10. And the next one, these are both like powers and radicals. They're all the same. So simply add 2 plus 10 and get 12, 8 to the 1/5. Now these two are not the same, but 54 can be simplified. Let's factor tree 54. 54 is 2 times 27, 27 is 3 times 9, and this is 3 and 3. So we're looking for trios here because it's a cube root. So the cube root, we have a trio of 3s that will come out, and the leftover 2 will stay in the house. Now I want to minus the cube root of 2. Notice these are now identical, and we can do 3 minus 1 and get 2 cube roots of 2. At this point, I'd like you to take a glance at the monitoring progress. You can try some if you think you can get these, but we'll definitely go over these tomorrow in class. Please list any questions you've had on the video so we can answer that as well.